Well, then the next stream I'd like to talk about is the companion string to data input stream. And we already saw it a little bit on the last presentation slide. Just to be able to utilize the data input stream, we had to create a data output stream. So we saw a little bit of the implementation, but I'd like to really hyper focus on this particular output stream. But it's the companion or partner to the previous stream we looked at. So a quick overview of this presentation is, well, we'll introduce the concept of a data output stream. We'll talk about the class declaration for a data output stream, which is going to be very similar to the data input stream we just saw. Again, we'll look at the constructors, the methods, and some examples. So a quick introduction to the data output stream in Java is it is a filter output stream that provides methods for writing Java standard data types. And we already kind of know this because we've seen it in action. We had to see it in action in order to be able to read data from a file that wrote it as primitive data types. So it enables you to conveniently write strings and all primitive data types, such as Boolean or ints or floats or longs, et cetera, to a stream. The Java data output stream first converts primitive data type values or strings into bytes, because it is a byte stream, and then writes them to the underlying output stream. So much like the filter input stream required a underlying input stream, and then it produced this functionality of being able to convert between bytes into your data types, it's the same thing. We need an underlying output stream, and then we can convert between the primitive data types to the underlying bytes. So using the data input stream, we can then read the data back in. Thus, data output stream works as a wrapper on a pre-existing output stream to filter data in the original stream. So the data output stream class declaration is as follows. You have the data output stream class that extends the filter output stream, which itself extends the output stream. It implements the interface data output, which has all the methods that are required inside the class to be able to cast from bytes into the necessary data type. It also implements closable, flushable, and auto-closable, all the things that an output stream needs to be able to do. And so the general declaration of the data output stream looks like this. So it's a public class data output stream. And so this extends the filter output stream, because a filter output stream essentially is the definition of one output stream that has it's a wrapper class, so it has these new methods that it enhances a pre-existing output stream with. So it does require a pre-existing output stream to be passed to its constructor, but it'll also implement the interface data output, which is going to have all the methods that we need to be able to do the casting we want. And again, the data output stream has existed in Java since Java 1. And so it's present in the java.io.dataOutputStream package. So that's what we'd have to import when we want to use it. So it only has a single constructor, just like its companion, the data input stream. So the data output stream requires an output stream instance, a reference to be passed to it. And so the constructor creates a data output stream object that uses the specified underlining output stream. And here the output stream defines which data will be written. So just to give you a code example of this, we would first need to construct a file output stream. And here in the file output stream, you might pass for instance, a string that represents the file name or file object or file descriptor instance or something like that, something that allows you to attach a stream to the file itself. And then once we get a reference to the file output stream, we would then go ahead and create a new data output stream around that file output stream. And we save a reference to that. And so these two statements basically wrap the data output stream around the file output stream. So again, if we wanted a visualization of this, right, we could think of initially having a file object, and we create a new file object if we want to, using the pathway, the file pathway, and saving that into a file instance. And then we can pass that file instance to create a new file output stream. So we build this file output stream wrapped around the file. And then once we have this file output stream, we can use that to pass to the constructor the data output stream and build our data output stream around that file output stream. And so again, the file output stream has all the underlying mechanisms on being able to go ahead and like create a stream into the file. And then we then have these additional behaviors. So the data output stream that we then apply on top of this file output stream that allows us to cast it into the actual data types. So we can read data from read as data, not as bytes or as characters, but as the primitive data types values from that file. And again, if we want to look at some constructors to append data to an existing, because to append, since we're talking about writing now, we can append data to an existing file. So recall that the constructors also have the append parameter. It's a Boolean parameter as the second parameter. So if we do that, that's part of the file output stream parameter. So we could also do this if we had some new file that we were passing in as the first parameter. Then as a second parameter, we could also pass in true, which meant that instead of like destroying the file and overwriting if there is a pre-existing file at that path, we can instead append our new data in addition to the pre-existing data. And then we would just, once we create that file output stream that is appending to the output stream as opposed to overriding it, then we would just pass that reference to that data output stream. So we don't change our constructor for our data output stream, but you would create a file output stream that's appending as opposed to not appending. And again, you could either do that as a file instance, or what we've been doing most of the time is just passing in as a string the file name, the file path. Okay, so let's talk about the data output stream methods. In addition to the methods that we inherit from output stream and filter output stream superclasses, the data output stream class uses methods defined by data output interface, and that's what makes it unique. Those are the methods that allows us to write our primitive data types into the file. So these methods convert values of primitive data type into a byte sequence. So it's not converting it into text, it's actually encoding it in the same byte representation that Java itself uses to encode those primitive data types, and then writes it to the underlying stream. So a list of the important methods provided by data output interface is as follows. So we have the ability to write a Boolean value. And so that's not going to return anything back. And we can pass in a primitive Boolean type, and that'll write one byte value to the output stream. We have the ability to write a byte, where again, a byte can be represented as an integer value. But what we're going to do is the method is going to write out a byte to the output stream as a 1 byte value. So even though we're passing in a integer value, we're not writing a 4 byte value out. We're really looking for an integer value between 0 to 255, or can be encoded in 1 byte, and that'll get written as a 1 byte sequence into our output stream. We have the ability to write bytes, plural, and here we can pass in a string. And so the method will write the lower byte of characters in a string to the underlying output stream as a sequence of bytes. We have the ability to write a single character, so we can pass in a character as a parameter. And so here, a character is composed of 2 bytes, and so we'll write the 2 byte sequence that defines the encoding of a character to the underlying output stream. And we can write characters, multiple characters, by passing in a string. And here the method writes a sequence of characters in a string to the underlying output stream, where it's 2 bytes per character. We could write a double value, where we pass in a double, and so that will write the double value to the underlying output stream. We have the ability to write a float, where we pass in a float, and that's going to write the float value to the output stream. We have the ability to write an int, where we can pass an int value, and that's going to write that int value into the underlining output stream. We have the ability to write a long, and that's going to take the long value and encode that as bytes into the underlining output stream. We have the ability to write a short value, which is effectively all the primitive data types we can write, and it can encode those as we'd expect it to into the output stream. And finally, we have the ability to write UTF, where we can pass in a string, and it'll actually encode that string into the string encoded value as bytes into our output stream, using UTF formatting as the encoding sequence. Okay, and just like all the other stream-related classes, all the IO classes, they do throw an exception, an IO exception. So if you were to use any of these methods, you have to either have your method throw an IO exception or handle it inside of try-catch block. I'm just going to keep harping on that so that it's just you understand that all IO requires that. Okay, so let's take an example of the data output stream. And actually, I think we're just going to use the exact same thing that we did for the data input stream, right? Because we did comparable work. So if you look at the source code here, and actually, let me jump over into IntelliJ. I'm going to open up my data output stream tester one, but this is going to be the exact same source code that we just looked at. So I'll walk through it pretty quickly. I'm going to import the data input stream because this is the companion to the data output stream. And so here in the sample code, I want to both write my primitive data to a file, but to prove that that data has been written to the file, I then have to read it back in to prove that I've been able to not only author it in its encoding, but I've been able to decipher it back into its original primitive data type format in Java. So I'll also import the data input stream as well as the data output stream. Since those are both filtered input streams and filtered output streams, I'm required to have an underlining input stream and output stream to pass to those constructors. So I'll go ahead and import the file input stream and file output stream classes. I'm also going to import the IO exception because we're just going to have our main method throw it. This is going to be my data output stream tester one, but the implementation is going to be the same as my data output input stream tester one. Main method throws the IO exception, so I don't have to use try catch blocks here. I'm going to do the exact same thing I did before. I'm going to create a file path that goes to my data.dat. I'm going to create a new file output stream where I'm going to be able to write a file to the output. So that output stream is going to attach itself and connect itself to that file. And it's going to send all of the output stream data into that file. And then around that file, we're going to create our data output stream, right? And so then we're going to grab a reference to that, and we'll just call that DOS. Then on our DOS, on our data output stream, we're going to actually write a string with write UTF. We're going to write an integer. We're going to write a double value. We're going to write a Boolean value. We're going to write a character. Then we're going to close everything up once we're done. And to prove that those have been encoded using the same encoding as the primitive data types, we're going to open that back up using the data input stream. Now, if I want to use the data input stream, I have to first open that file path up as a file input stream and then use that file input stream to build my data input stream around it. And then once I do that, I can read as a UTF that string, and then the next thing will be an integer value, and then the next value will be a double, then the next value is going to be a Boolean, the next value is going to be a char. And I want to just highlight, now if I run this, we'll see that we should go ahead and get those values displayed back out. So I wrote them to that file, and then I'm able to parse the data back out. And just to highlight this, let me open this, and I want you to see that my data.dat is a binary file. It's not human readable. So all those encodings are in byte sequences. It's not in text sequences, except for the thing encoded in UTF-8. Well, the string, welcome to Java world, is encoded as text, but everything else you'll see is in binary. And so I'm able to reparse it and actually be able to read it back out here. And again, I'm able to do that because of the functionality that data output stream provides to me. Excellent. Very good. So those can be very useful if you want to store primitive data types and read primitive data types from a file. There's another way that we can actually serialize more complex data in the form of objects and in the form of arrays, in the form of reference data types, and that's called serialization. And we'll look at that later, but this is kind of like a motivator. It's like a preface to being able to serialize our actual Java application data so that we can read it, we could write it to a file and read it back in. So here you could, if it's just going to be primitive data that you're doing that, you could just use the data input and output streams. But if it's more complex, if it's a reference data type, then we'll talk about how to do that in a future section. Excellent. So is there any questions about the data output streams?